Greetings and salutations. Peace and y'all. We're on part 4 of grade 4 of the Show Your Work Hardest Math Problems. A link to previous versions of these videos can be found at GregsTutoringNYC.com/hardest-math. You can find that the link at the bottom there. Otherwise, you just go GregsTutoringNYC.com, and on the front page there's a link to it maybe halfway down the page or so on. Not too hard to find. All right, so we're doing this series. I did a whole bunch already. You can find that link about multiple choice. That took a few months to do. I started this maybe a month ago, starting from grade 3. I'm now about 10 videos deep into it and so on. I'm going to do grade 4, grade 5, grade 6, grade 7, grade 8. We're categorizing what I'm calling the hardest math problems. I'm sourcing from the New York State exam, which was given to hundreds of thousands of kids over multiple years. Different versions of it, where each time I'm doing this, I'm using a different year of it, where basically hundreds of thousands of the kids got certain problems wrong. So that's the criteria that I'm using to decide hardest math problem. Remembering that sometimes it's not the raw math that kids are making the mistakes on. It could be their attention to detail, they're not reading the question properly, they're only answering half the question, stuff like that. Yet at the end of the day, that's about answering a question, and it's it's still involved in your proficiency level of math, even though it's not directly always math. With that in mind, even though I'm sourcing from the New York State test, I'm not doing test prep. That's not my goal here. My goal is to try to communicate the concepts and topics of each grade level to the child. Like if you watch the grade 3 series, or whether multiple choice or the Show Your Work one, a lot of that was about knowing your multiplication table. And this year, it's involving adding angles, doing multiple digit multiplication and division, things like that. So each year is going to add on to the previous year's knowledge. And with that in mind, remember, saying we're at grade level means you may know more than grade level, and there may be some things you don't know. So there's an overlap that goes back and forth between them. Also, given that I'm using the New York State exams, this is not a New York-centric conversation. This is basically about topics. I'm focusing on at a grade level, but it's really about the topic. That's really the focus, the topic and the concept, and that's what I'm going to try to do. So as we explore, I take my time. Each of these is about an hour. Sometimes if it goes longer, I split into 2 parts. The second part might be half an hour. These are just bite-sized pieces of what's called grade level or age level math. If you're an accelerated student, then maybe you should be bumping it up into the next grade. And it also depends on what middle school you go to, your teacher, your own motivational situation, etc., etc. All right? So with that in mind, let's get to it. Okay, so the first problem, let me just make sure we're live here. Yes, we are. By the way, I have the chat, and the chat is turned off for now, so I'm just doing this. So I want to make sure, since this is for grade 4, that I'm being clear and not interrupted on stuff. I do a whole bunch of, I have hundreds of videos online already at the channel. You could also get that at GregsTutoringNYC.com/YouTube. If you go there, it'll ricochet into my YouTube channel. You don't have to click on anything else. It auto ricochets onto there. And while we're at it, at the bottom of the screen, you have GregsTutoringNYC@gmail.com. Hit me up for any reason whatsoever, including tutoring. But if you had general questions, hey, I'm here offering free video. So obviously, you know I am accessible. All right? All right, so let me get my tablet loaded here. All right, so I like to look at diagrams first. So in this first one here, I have 2 interacting. Diagram A shows 2 intersecting lines. Okay, we know they're a line because there's arrows on both sides of it, right? And they intersect right there. So let me just call that point A. Okay, the next one, diagram B, also shows 2 intersecting lines, but it appears to me, and I don't know yet, these appear to be right angles, every single one of these, right? This little squarey thing, and I'm just using them to different sizes to indicate that that appears to be 90, that appears to be 90, that appears to be 90, and that appears to be 90, okay? On many exams, illustrations are not normally drawn to scale unless it's a coordinate grid, where you have an X and a Y axis, and on some charts as well. So, so all we're doing now is just looking at that and guessing. And we have two lines here, let's call this line 1 and line 2, that do not appear to intersect. Now, if we were to elongate them and go like 1,000,000 miles away, they might eventually intersect. But these, so by the way, this is called perpendicular. So we'll just say perp, and this is parallel. Para. Okay. So when they intersect at a 90-degree angle, they're perpendicular. That's diagram B. When they intersect at diagram C, they don't intersect. So we believe they're parallel. Okay. And by the way, we can just talk about stuff here. This angle here is exactly the same as that angle there, and they both seem to be acute angles. And this double one here I'm doing here is exactly the same as this double one over here, and they both seem to be obtuse. Okay, I don't know if that's what the question's asking, but so now that we kind of beat the illustrations to death, let's kind of go back into here. Which diagram below appears to show a pair of perpendicular lines? Okay, right? Which appears to show it. Well, that's what I said before. We're not sure. So these appear to each be 90. Okay, so the answer would be B. There's a second part to the question. They just don't want your answer. They want you to explain it. So you just can't say B because it is perpendicular. Okay, that's not acceptable. You can't just say that. You have to bring forth some notion that you understand what perpendicular lines are. Okay, so you can say because each angle meets at 90 degrees or something. That's what they're looking for. So when I said earlier that it's not always about math, some kids may know the answer is B and they may know the reason why, but if they didn't say it in the explanation, then they're not going to get the credit for it. Okay, so this turns out to be an attention to detail thing as well. In the real world, if you're trying to solve a math problem, there's often parts to it and other explanations to it. Because you could say, oh, that's not fair, I knew the math. Well, there's certain test-taking skills you need to know and you have to follow. And even though I said I want to concentrate on concepts, I think it goes beyond just the test-taking skill. When you're asked the question, there's often ancillary aspects to it, where you may have to go up and follow it up with a presentation, or write a report about it, or use that value for something else, and so on. So you'll often not just said like, hey, can you do this computation for 3 months and come back to give me a number? Right? That's rare that happens. So it's normally an involved description where you have to read some sort of instructions, or you have to write the instructions, right? It's not enough to say, oh, look, I built this building or something. Whatever. There's often, you need a blueprint, you need, yada, yada. So this is part of that training involved in it. All right, so that's kind of where we're going here. So this is basically, in terms of focusing on concepts, this was a geometry question, okay? It deals with lines. It also deals with angles, okay? But it's a line and angle question, okay? So even though I labeled obtuse and acute, I was going further than what the question was asking. And it was just observing it real quick, right? I'm doing this in my head. I'm looking at the 3 illustrations, and bing, bang, boom, in a microsecond. Oh, that's acute, that's obtuse, that's perpendicular, that's parallel. Now what's the question? So I'm not wasting time looking at the illustrations. Okay, and the illustrations, first of all, are communicating something to me. All right? So I don't know what the question is, and I want to get myself set up because sometimes the words in the question drags your brain to somewhere it shouldn't be. So if you focus on the illustrations, even though they're incomplete, you can start getting some idea of what's going to happen. And often you can even predict what the answer is going to be, all right? So that's really where the focus is here. So again, this is about geometry, lines and angle, in particular, intersecting, perpendicular, and parallel lines, okay? And a key thing here was up here, right? We still don't know that these are actually 90-degree angles. We still don't know that these are actually really parallel, but they appear to be, okay? That's all it's asking you. That's all that's going on here, okay? So that's that one. Okay, we have no illustration here, but we have a word question, okay? So let's go at it. The workers at the Cameron's flower shop are putting 1,323 flowers into vases for a party. Each vase must hold 8 flowers. Okay? What is the total number of vases the workers can fill? Okay? So there's 1,323 flowers, and each vase can hold 8. So there's two things in conflict. Sometimes when it's total normally can mean addition or multiplication. Okay? But oddly, total can also mean subtraction and division. Right? Unless it says something like the total sum, you can't just use the word total to figure that out. You have to logically run through this, right? So if we use simpler numbers, and she said she had 10 flowers, okay? And I'm going to put that in parentheses, not the problem. And each vase could hold 2 flowers. I think you can all see that she needs 5 vases, right? Each vase can hold 2, and there's 10 flowers. That means 5. So what we did was, we did 2 into 10 and got 5. Now this is actually a suggestion I'm giving you guys. Sometimes the ugly and bigger numbers start convoluting yourself. Like I said earlier about the words dragging your mind somewhere else. Start by using simple numbers until you can actually run a mini experiment. Use simpler numbers so that you can understand what is the operations involved. Okay? So this is actually an operations question. Okay, what I mean by operations is with arithmetic operations. These here. Okay, and it could be other operations like percent, square root, etc., right? Exponents, absolute value, right? There's a whole bunch of operations that can be done. And many that you still don't even know, like a factorial, you're going to probably learn in 2 years or something after, by the time you get to 6th and 7th and even 8th grade, and certainly in high school, all right? So this is really an operations question. What am I being asked to do? So we used the simpler number. We established a model, an exemplar form. So it means what we're doing is dividing this by 8. Okay? So 8 goes into 1. And let me just write that neater, because my 1323 is a little sloppy. So 8 goes into 1, it doesn't. 8 goes into 13 one time, right? With 5 left over. So I'm doing short division. You guys may want to do long division. So 8 goes into 52 6 times. 6 times 8 is 48. And we're left with 4 left over. 8 goes into 43 5 times with 3 left over. There's nothing more we can do. So we can either do decimals or do R3. Okay? There's other ways to do division. This is the way I do it. Okay? There's also longhand, which is the second most common way. where we can do 8 into 13, 23, which is really exactly what I did. Oops, that's a 3. 8 goes into 1 again. 8 goes into 13. One time we write 8, and we do the subtraction, right? Yeah? So we're going to get 5 right here. We're going to drop down to 2. Okay? Do you notice the 5 that I did right there? So I still get 52 no matter how you slice it. Now 8 goes into 52. 6 times we get 48. We subtract 48 from there. And we get 4 left over, and we drop down to 3. Okay? See my 4 right there? So it's the same thing, just compacting it. Okay? And then 8 goes into 43. How many times? 5 times. We subtract 40. We get 3 left over. Okay, for this example, we could have done decimal points and gone continued. So that would have been 8 into 30, and we could have got 0.3. That's 24, and we would get 6. So there's a bunch of decimal points we could have got here. And this is also stated, if we use this form, as 165 and 3/8. Okay, we could have done that too. All right. All right. So now we have a number. We have 165 with the fraction left over, or in this case, a decimal left over. So it says, what's the total number of vases the works can fill completely? They can completely do 165. Okay, and that's the answer. So this is about ripping apart a word problem. This was really about operations and deciding what operation makes sense. Because we had to do the division, this is also about division and multiplication. Wait, how could it be about multiplication? Because you had to know that if we did, say, 8 into the 52 here, you may have had to go on the side and do 8 times 4 was 32, 8 times 5 was 40, right? And then 8 times 6 was 48, 8 times 7 is 56. Wait, 56 is too high. So this involves knowing your multiplication table and doing multiplication even though we're doing division, right? Because every time we get these little interim values here, we still need to do a multiplication to figure out how many times can 8 go into that, or whatever the outside number happens to have been, right? The divisor. All right, so this is also tying back to the concept that came up a lot in the grade 3 examples that I did, both the multiple choice and the show you work. This is about equal parts. We're trying to distribute the 1,323 into equal parts of 8, right? So this is still dealing with that same notion of how can we get equal parts into it. And complete. So complete was the operative word here. This is an important word in the sentence. This is why it's important to read what you're being given and try to figure out what they're asking out of you. So if some kids are going to get this far and then say the answer is 166 with that last thought in mind, it's not, okay? This is also not the answer they're looking for. This is the literal answer to the division, but it's not the answer they're looking for. So if you answered 165 and 3/8 in this slot here, and that's a slight hint, they're asking for vases. You can't really get 3/8 of a vase. You could talk about filling it. If we're talking about water, then it might be a harder question to ask. But if they're asking, they're filling flowers into vases, I don't know how you get 3/8 of a vase. All right, so there's always a slight hint in the units that they give you here to kind of reorient yourself and get yourself a little straightened out. On the same note, the answer was not 1383. 1323 times 8. Okay, that would have given you an answer like, I think, about 10,000, around 10K. You should know that if they started out with that 1,300 flowers and they're going to put it into all those into only 8 vases, right? You should know that they didn't end up with 10,000. So it kind of gives you a way to gauge. In fact, this should kind of be your initial estimate, right? That if when you were doing this experimentation I was talking about here, like the 2 into the 10, you should be gauging that. Like, what if I did 10 times 2, or 5 times 2, whatever my, 10 times 2 and got 20. Does that make sense? If I started out with 10 flowers, I ended up with 20 vases? Huh? So that you know it's not multiplication at that point, right? So that's the logic that you have to go through. First of all, you should be morphing into instinctually be able to read these and be able to decide. But there's no reason you still can't do the little experiment and figure it out. So if you were to estimate, you have about 1,500 flowers, right? 1,500 flowers and about 10 vases. That's about 150 flowers per vase. And that's the answer you got. 165 is a close enough estimate to 160, right? If you got 160 and your estimate was like 1,000, then there's something wrong. So you always have ways, even if it's imprecise, to double check what's going on. All right, and this is important. This is about your numeracy, your mathematical proficiency, your no hesitation math, just your fluidity, things like that. This is all tied in with that. Okay. And this is an example, a good example. We had some examples in earlier problems, like grade 3, where if the 1320 was like, let's say it was 100, okay, you could have done a solution where you counted up, 8, 16, 24. You can get to 100 pretty fast that way. And then realize, oh, it was 12. 12 of them would have got me there if it was 100, right? Because 8 times 12 is 96. You're supposed to know that, right? So it would have been 12, right? But given this is 1,323, are you really going to spend 15 minutes counting up by 8 and probably making a whole number of mistakes until you finally get to somewhere around 1323? Nah, you don't have the time for that. So that's why, even though they were viable and allowable answers to previous year's examples, it makes no sense from this point on to do this count up kind of stuff. So it's worth knowing your multiplication table, not only to 10 by 10, but bump it up to at least 12 by 12, and if you can pull it off, do 20 by 20, right? That's your ultimate goal, is to get to the 20 by 20. And there we go for this question, all right? Okay, 41. Samantha, so this is another word problem. Samantha walks a total of 2/3 of a mile to get to school and from school each day. She does 2/3 of a mile to do this, right? That's what it says. It's not each direction. It doesn't say she walks 2/3 of a mile to get to school and 2/3 of a mile to get back from school. It says she walks a total of 2/3 of a mile to do this, get to and from school each day. Write an expression, so they're not asking you to solve this. Okay? Write an expression, so this is the first question they're asking you, that can be used to find the total number of miles. And then the second question is here. Then evaluate the expression. Finally give the answer. So they want you to write an expression that maps into that. Okay? So what we have is, if she goes 2/3 of a mile, and we said D was the number of days, then that's the expression. 2/3 D. Right? Okay. It would have also been acceptable, and you have to give words here if you do that, to have said 2/3 times 5. That's your expression. Okay? And your expression for grade 4 has to be written left to right. You can't stack it up and down. You can't break it in two pieces. And it says "and." Okay, if you write two expressions, that's no good. You can only write one. Okay, at least for the initial thing. Once you wrote that, maybe in your show your work, you might want to split it up into further parts. But at least for the initial answer, they're asking for one and only one expression that's written left to right on the page. It's a number sentence, right? That's what they're looking for. Okay? It's an expression, so there's not necessarily an equal sign in it, even though they would probably accept that. Okay, so you could have wrote the answer or something, or X or something that they probably would have allowed that, but technically it's not what they're looking for. They're just looking for the most minimal computation to get the right answer. All right? So now the show you work is to actually do it. So if I have 2/3 times 5, okay, any number is itself over 1. So this is the same as 5 over 1. Okay, so what we do is we multiply the numerators, so that will give us 10, and we multiply the denominators, and that will give us 3. Okay, so that's our answer. We can simplify it to be 3 1/3 if we want. Okay, but before you do that, look at the answer. It says miles walked. Okay, so both are acceptable. It doesn't say it has to be in fraction form or whatever. So we have a top-heavy fraction here because the numerator is larger than the denominator. That's okay. We have a mixed fraction here. If you wanted to, you could have also wrote it as a decimal, 3.333. And if anybody knows, there's a bar over that, which means the 3 continues. This is also acceptable, right? They're not asking you to do that. So usually one of these two forms is what they're asking you to do. Okay? And that's the full extent of this problem. It's nothing worse. It's nothing less. You could have done 2/3 plus 2/3 plus 2/3 plus 2/3. That's 4 plus 2/3. And 2, 4, 6, 8, 10, and got 10/3 that way. Okay, and then you're back to the same question and the same answer. This runs into the concern I just wrote from the last problem. If instead of 5 days, it said 55 days, are you really going to write out 55 2/3 and add them all up together? Okay, you need to get at the next level of mathematical proficiency, right? So, and it makes sense if there was only 2, you wouldn't necessarily do 2 times 2. You would probably just do 2 plus 2. But you need to bump it up to really the next level here. And by the way, on this 2/3 times 5 over 1 thing, some of you are still adding. You're making that 7 and that 4. No, you multiply your numerators, so this is no good. You multiply your numerators, and then you multiply your denominators. You don't add. Okay, so that's a no-go. So this is also about knowing fractions. This is also equal parts. Each day, she went 2/3 of a mile. The same part, equally over a number of days. Right? So this is also about equal day things. It's about knowing your multiplication table. This was simple multiplication, 5 times 2 and stuff, but it's still about knowing it. We could have also done this visually, just like the fraction over here. We could have taken 5 things. 2, 3, 4, 5, and split each of those into thirds. And then shaded 2/3 of each one. And then counted 2, 4, 6, 8, 10. And we could have got 10/3 that way. Again, this runs into the same thing. What if it was 55 days, right? So it's cool to visualize some of these and do the little experiments, but at the end of the day, you have to move on from that. And just to check. So it might be okay to do this visualization for 3 of them, just to make sure that you got it right and it's making sense to you. But at the end of the day, you really want to do this straight up multiplication kind of solution and just get there. And by the way, this equal parts concept, in this case, it's about multiples. So we're looking for multiples of 2/3. How many 2/3 do we need? We have 5 of them, right? So that's what we're dealing. Traditionally, if I have A times B, traditionally this second number is the multiplicand. Okay? It doesn't actually work that way in all examples, but that's normally what they're looking for. So when you have the 2/3 times 5, the 5 is our multiplier, right? We're getting 5 2/3. You could argue we're also getting 2/3 5s, but we are. But that's not the approach you're taking in this example. Okay. Yeah. That's 41. Okay, another word question. So Cindy recycled 54 pounds of paper. Stop. Think about what's going on. There's 54 pounds of paper. We don't know if that's important or not yet. She recycled 9 times as many pounds of paper as Monica. So let's start recording that. Cynthia recycled 54 pounds. Okay. Cynthia also recycled 9 times as many as Monica. Yeah? Cynthia did 54 pounds. She also did 9 times as Monica. Write an equation that can be used to find M, the number of pounds Monica. So I use an uppercase M. So let me change that to a lowercase m. Doesn't really matter. The number of pounds recycled. Then solve the equation. So if you notice, this is the first part again. This is the second part. If you don't write an equation, then you don't get the credit. Okay, and if your equation is not left to right, then you don't get the credit. Okay, so I'm not going to go through that speech again. So what we have here then is, if this is true here, then Cynthia divided by 9 is Monica. Okay, we already know, so this is the answer to number 1. Okay, for 2, we know based from here that Cynthia is 54. So what we have is 54 over 9 is going to be equal to 6. Okay, run through, read the words again, see if your answer makes sense. Okay, see if your answer makes sense, because this is not about doing 54 times 9. Okay, that's a no-go. And it's also not about taking the 6 and adding it to 54 and making it 60 or something like that. It was also about the number of pounds because we solved for M. M is what we're looking for, right? M was 6, not Cindy. I keep saying Cynthia, it was Cindy. Okay? So this is about knowing which operation to use again. Once you figure that out, it's about division, right? Once you figure that out, it's about your multiplication table one more time. Also, as a word problem, it's also realizing that they're asking you for 2 answers. One is the equation and one is the solution, right? You have to do both. Okay, and by the way, the equation was not 54 minus 9. That's just broken. That doesn't make sense for what's going on here. As I said earlier, it was not 54 plus 6. Once you get to 6, it's also not 54 minus 6. Okay, so we can't do that either. It's also not about 54 times 9. That one just gives us a number like close to 500. That's just, where do you even get that from logically when you read this question? It doesn't flow, and this ties into my suggestions earlier about your estimations, right? Right, if we bring this to 50 or 55 or 60 and this to 10, right? We can make some guesses here about kind of what the answer should be just using logical sense. Or we could have made this 2, right? And she started out with 10 pounds. Use the experiment with tiny numbers first. Let it make sense. Figure out what your experiment yields in terms of operations. Write it on the side. Try to figure out the formula from that. And then try to apply it to the actual numbers they gave. Okay, and see if it still makes sense. And by the way, when you use the tiny numbers, avoid 0 and avoid 1. And there's enough cases where you should even avoid 2. Okay? So normally when you're using experimental numbers, start from 3 and above. Okay? So, and if you can, max out your test numbers at 10. Because you're getting into a more involved double-digit multiplication or addition or whatever. Just keep it simple so you can conceptually figure it out. These problems are not advanced calculus. They're not something Einstein is being asked to solve, right? These are grade 4 problems at this level. Even when you get to grade 5, 6, 7, 8, even in high school, there's a cap, there's a capacity to what you're really being asked to address. And remember, even though the state test involves some weird questions and so on here, this is about concepts, right? It's always about concepts. So they're not always going to torch you with weird arithmetic and stuff like that. So this is really where you want to go to. So this is about writing equations. It's about knowing what operations are involved. It's about knowing your multiplication table again. And again, realizing that this, again, was a 2-step question. And by the way, to solve this here, you could have counted up by 9s, 9, 18, 27. Don't do that. Okay, it works, but don't do it. Because again, instead of 54, this could have been 10,000, right? You don't want to count up. You want to use what you know mathematically and do it efficiently, right? Counting up, unless the number was 18, where you just go 918, counting up is just inefficient, it's error-prone, a whole bunch of stuff like that. It doesn't mean everything is not error-prone. Everything has a level of risk and error to it, but you want to hedge your bets. And as you get more proficient in your divisions, in your multiplications, in your interpretation of the word problems, in your little experiments that you run, all these things that you do, you're going to find that the practice makes you perfect, right? You're going to get closer and closer to the unicorn. Yeah, that's where you want to be. Okay, next question. And let me just check the time here. With 37 minutes. All right, we should probably finish this in less than an hour. Okay, another thing I'm noticing just immediately off the bat, there are fractions involved. Yeah, we love fractions. Of the animals at a pet show, 3/8 were cat and 4/8 were dogs. Cool, end of sentence. The rest of the animals were rabbits. Okay, what fraction of the animals at the pet show were rabbits? So it seems to me that together they're a whole. So one is a whole. So the whole is equal to cats plus dogs plus the rest, which are rabbits. So R works for rest and for rabbits. They are not asking you to write an equation. However, why not write one anyway? So that you can logically map the math and the English back and forth. So the cats plus the dogs plus the rabbits is all of them. So this is the sum of the parts. Gives us the whole. Yeah? Right? The sum of the parts gives us the whole. So now that we have the equation, let's just start filling in the blanks. So the whole is equal to 3/8, because there was 3/8 cats, 4/8 dogs, plus the rabbits. Okay. The next step we're going to do is, we notice a whole, we can replace this by 8/8. Okay. We can combine these two, that's a really badly written 8, to 7/8. Okay, if we subtract 7/8 from both sides here, or you can actually see the answer already, we can see that 1/8 is the share of rabbits. Okay, and we can plug it back in now. 3/8 plus 4/8 plus 1/8 is 8/8. Oh yeah, we got it, right? So this one wasn't too bad of a problem. It deals with fractions. It deals with equal parts. It deals with the sum of all the parts producing a whole. Okay? This was not 3/8 times 4/8, right? They're asking for the fraction of rabbits. If all the animals are a whole, we can't be getting large numbers like that. So this is no good. This was not about 3/8 minus 4/8, which, by the way, would give us minus 1/8. There was minus 1/8 rabbit? No, that's a no-go. It also was not about 4/8 minus 3/8 equals 1/8. Okay, so this is interesting, because if you solved it this way, you would have accidentally gotten the right answer. So that's the point of the show you works. If it was multiple choice, they don't check your paper to see your scrap work. So if it was multiple choice and 1/8 was an answer, and it should be, because that was the answer, and you solved it wrong, they would never know. So here, you wouldn't get any points. You wouldn't get any points. Okay? You would only get points if you showed the correct way to do it. Right? So you can't accidentally say this is your answer over here. Right? That's a no-go. That's not a way to get points with that. All right? We could have also done this visually. And again, I'm indicating you guys should stop moving away from that. In any event, I'm going to cut it in half. I'm going to cut each half in half. That's quarters. And now we're going to cut each quarter in half. So now I have each. Okay? So if we follow it, 3/8 for cats. So we have cat, cat, cat. 4/8 with dogs. So we have dog, 2, 3, 4. Okay? And look what we're left with, this one here. That's the rest. So we have 1/8, because these were equal parts, right? We have 1/8 left. Okay, so we could have done it visually as well. There's really no reason to be doing it visually at this point. You guys need to start thinking mathematically, right? So it's not that these other ways are not invalid answers. They are totally valid, but you need to start bumping up your numeracy and fluidity to get you to the next step to where you need to go. First of all, it's great you can get the right answer if you can do it that way. I'm indicating that you should be morphing to the alternate, which is the raw math. This is math, so why not do the raw math, right? An example is if you're learning, say, Spanish. It can be hard to map words back and forth and then whole sentences. And in fact, you can end up saying your Spanish sentence wrong if you literally map each word one at a time, because there's phrases and cliches and different ways to combo words and stuff like that. So when I was a student in high school, I took French as well. I took French in college, and there was a line in the sand where I was like, I need to stop doing this at a one-to-one level, and I have to kind of become one with the French. I have to, that sounds Zenish, but it was holding me back to do the mapping word at a time. I had to start looking at the French as a sentence or even a paragraph and just absorb myself into French and become one with it. And that was kind of a paradigm shift for me to be able to get over that hurdle. It was challenging for me. So you guys, this is kind of the analogy that I'm suggesting to you guys about stuff like this as well. So one key is this one thing here. Okay, even if you didn't write this equation like I did here, right? This concept of the whole, or one, and I have it here again here. The sum of the parts is the whole. This concept of 1 is important, okay? And on that same note, this puts the answer. They don't give us a unit suggestion here. So the problem is we computed the fraction was 1/8, and some kids are going to write 1 there, right? That means the whole. It doesn't mean 1/8. So you just can't use the numerator. You have to give the whole fraction. So the whole complete answer was 1/8. So that's a shame. A lot of kids can compute the answer correctly, and then they come down here and write the number 1. And the teacher grading this has no clue where they got the 1 from. Did they pick it from the numerator, or did they just think now that all the animals are accounted for, that they're talking about a whole? The teacher doesn't know. So the teacher has no choice but to mark them wrong. Okay? So this is not good. On the same note, with this 4/8 and 4/8 and 3/8, right? The right answer was to add them together. Okay, this is not equal to 7/16. Okay, that's no good. Can no do. This is not equal to 7/16. So be careful. Be careful. Right? So that's our concepts for that. I mentioned them earlier. Okay, we're back to another geometry question. It definitely looks like it's involving angles. So we have triangle ABC. We have this DC line intersecting through there, creating this angle 67 here. And this other one, I'm going to double that, being N. It looks like, and I could be wrong, so I'm going to do this gigantically. It looks like this is 90 degrees here. I'm not sure. Okay. I know this is acute. This is acute. Okay. I don't know where they're going for this. They probably want us to solve what the value of N is. So there's nothing else I can grok out of the illustration. Let's go to the words. Right triangle ABC is shown here. So A, B to C, and then we map back, right? So let me just get rid of that, just to make that clear. So it says write an equation. That's our first question. That can be used, and then there's a then here. So this is our second thing we have to do. Okay, so again, this is a multi-part question. If you only answer one part, if you only write the equation, you're not going to get all the points. You see me saying the same thing over and over and over again over all these streams? But you guys just keep skipping over these parts. So first of all, write an equation that can be used to determine the angle measure in degrees, okay, of angle DBC. So that's, if we follow, so the way you do this, the same for is if there's an angle. If this was X, this was A, and this was W, okay? The midpoint, the middle symbol is the middle. So this angle right here would be X, A, W. I'm going to start from here, go to the middle one, hop to the middle one, and then go to the last one, okay? I could have also started at the W and did WAX. Those are both valid ways to approach this. There's different reasons for choosing the two different orders, but technically they are both valid ways to talk about this inner angle, especially if it says inner. And sometimes it uses the little symbol that looks like this. It looks like a less than sign. A less than sign normally goes like that, where this leg here is still slanted. The angle symbol is a slant, and normally a straight line across, right? So let me write that one more time, like that, okay? Sometimes when I'm doing a text file, I'll use this to mean angle. So I might sometimes write angle ABC or something like that, Okay, and you can figure it out by context. But if you're not in a text file and you have like Microsoft Word or Google Docs, you can certainly fit it in and use the right symbol. Okay, it sometimes involves extra keystrokes on your keyboard to get it, like using the Control key or the Option key or something like that. Okay, I'm a little sidebar there. So the middle letter, right? The middle letter is the angle. So let me get rid of everything I wrote on here so that we're going to declutter the screen. Because a lot of kids got this question wrong. In fact, if I'm not mistaken, most kids got this was the largest number of points lost on this exam was on this question. All right, so let's re-go into it one more time. So it says right triangle ABC. So B is the middle angle. So it's telling us that angle B is indeed a right angle. Remember before I said I wasn't sure? So let me write that a little neater this time. Okay, so that is indeed, that's the middle, and therefore it's 90. Okay, write an equation that can be used to determine the angle measure and degrees of angle DBC. So if we did what I just said before, B is the middle letter. So that's the angle they're talking about. So if I was to highlight that, let me change the color of the pen for a second. Let me use green so it doesn't interfere too much. I'll use let me use orange. So D to B up to C. All right? Right? We're using the middle letter to find out where the exact angle is. That means the angle's right there. So indeed, that was angle N. Okay? So by virtue of knowing this was a right triangle, we can do that computation. So what's the equation? What would the equation be? Right? Wouldn't it be angle ABC is equal to 67 plus N. So that's one acceptable form. Another acceptable form of the equation was 90 equals 67 plus N. Okay? And that's using what they gave you. So this here is really what they're asking for. Okay? So at this point, you satisfied the first part of the equation here, the question rather, right? Let N represent the measure of angle DBC they're talking about in the equation. Okay? So that second sentence supports the first sentence. And then there's a then here. Then determine the measure of N. So now they're asking us to solve it. Okay? So we could subtract both sides by 67. That goes away. We're going to subtract 67 here. Okay? And we're going to get 23 equals N. Some of you write 33, right? But if we actually do the subtraction, because many of you do this in your head, and for questions like this, you often should not. We can't take 7 from 0, so we have to borrow from here. This becomes an 8. We're going to borrow a whole unit. And this becomes 10. So now we have 10 minus 7 is 3, and 8 minus 6 is 2, right? So this is your basic subtraction operations. And a lot of you guys still at grade 4, I work with kids in grade 5, 6, 7, 8, who are still doing the subtraction incorrectly. Okay, and it's so easy to do 90 minus 67 in your head because 90 minus 60 is 30 and assume that the answer is 33. It's not. Stop doing that. Okay. What some students do as well for this problem in particular is they do 90 plus 67. Okay, and they get 157 as the answer. No, don't do that. Don't do that. Can't you see that the angle, it first of all it tells us it's a right triangle, but you can't you see that this angle ABC is not an obtuse angle, so it can't possibly be 157, right? Acute is less than 90. A right angle is equal to 90 and an obtuse is greater than 90. So how could the answer possibly be 157, right? So this is about, again, about writing equations, and it has to be left to right, okay? I couldn't have said, if you wrote this as 67 plus n equals 90, they're not going to mark you right for that. Okay, they're looking for left to right equations being written out. Okay, so this was a multiple question again. It didn't involve multiplication. It involved knowing that you had to do addition in the equation, and then to actually solve it, use subtraction. Okay, and definitely don't count up or down with this. And it involves doing, double-digit subtraction, just like what happened here. All right. Yeah, so it's geometry and involved angles. This is all this was really about. We already knew that A, B, D, let me write that better. A, B, D, if we look at the middle here, okay, and I'm going to change the color for this. If I go from A to B to D, okay, ABD is this angle right there. We know that's 67. They gave it to us. All right? And the angle DBC we computed was 23. And we can double check it. That's 67 plus 23. 7 plus 3 is 10, 0. Carame 1, 6, 7, 8, 9 is 90. Booyah! Yeah! Okay? So that's 44. And again, they're giving us a hint. Make sure your units make sense. They're not looking for the length of a side or anything like that. They're giving you a second hint on this one. They're actually saying n equals, so that you know which angle you're looking for. How much better could you get at this? So that's a really great thing. They gave you a hint on that. Even despite all that, most kids got this question wrong. Again, we're talking about 100,000 kids. Okay, I believe this is the last question. Yep, we're finally there. So by the way, we're looking for, we know just by this that we're looking for erasers. Okay, there is no illustration. So we're going to try to go at this again and try to understand it's a word question. Okay, a teacher buys 8 packs of orange erasers. So the teacher buys 8. Whoops, let me write that better. 8 orange, right? And 6 erasers. Okay, I'm not sure if the color, no, wait, I did that wrong. The color does matter because the other one's orange. So the teacher buys 8 orange and 6 blue. Okay, let's see if those letters so far are good for us. For his classroom, there are 24 orange erasers in a pack. So a pack of orange has 24 erasers. Okay, so I'm taking this a step at a time. And 28 blue erasers in a pack. So a pack of blue is 28 erasers. Okay, what is the total number of erasers the teacher buys for his classroom? Remember, with total, we're probably looking at addition, or we could be looking at multiplication, or some other operation. So let's reread the question and try to make sense out of it. Okay? A teacher buys 8 packs of orange erasers. Cool. The teacher also buys 6 packs of blue erasers. Double cool. Okay? There are 24 orange erasers in a pack. So it seems to me, if we work just on the orange for a second, If there's 24 in a pack and the teacher bought 8 of them, then we're multiplying that by 8. Okay, that's how we're going to get the subtotal of the orange erasers, right? If a pack, let me change the color here for a second. If a pack had 3 orange erasers in it, and he bought 5 packs, wouldn't he have bought 15? 3, right? 3 times 5. So we're dealing with multiplication. So we do into 24 times 8. 8 times 4 is 32. 3, 16, 17. We get 192 orange. That's the total of the orange. Now, we have to do the same thing. So there are 24 orange and 28 in a pack. If he buys 6 packs of the blue, then we're going to do something similar there. We're going to have 28 times 6. And again, use tiny numbers. Use 3 here. If there's 3 in a pack, and again he had 5, he has 15. Oh, I'm still doing multiplication. So 6 times 8 is 48. Carry my 4, 6, 12, 188, I believe is the answer, if I did that correctly. This is nasty enough. I'm going to reread everything one more time and check my calculations, and then let's go to the next step. So a teacher buys 8 packs. I have dyslexia too, so I want to make sure I copied stuff. The teacher buys 8 packs of orange erasers and 6 packs of blue. So I have that 8 orange and 6 blue. Cool. There are 24 orange. Cool. And 24 blue. Cool. What is the total number? So 24 times 8. 8 times 4 is 32. 3, 16, 19. Good. 8, 6 times 8 is 48. 8. Carry that. 12. This should be a 6. Okay, so I understood the question right. And it says, what's the total number of erasers? So this is blue. So what we did was we computed this number here, right? 8 orange is going to give us 192 altogether. And the 6 packs of blue is 168. Okay, so we have to do 192 plus 168. Okay, 8 plus 2 is 10, 0. Carame 1. 9 plus 1 is 10, 6. Carame 1. And my answer should be 360. By the way, for you guys, just a hint that I give this, and I don't give this all the time. Sometimes it's worth flipping the 2 numbers and making sure you still get the same answer. 8 plus 2, 0. Carame 1. I normally like to start with 10, so I would add the 9 and 1 anyway to get 10 and just add the 6. That's easier to me. But let's just do it another way. 1 plus 6 is 7, and 7 plus 9 is 16. 6. Carame 1, so I still get 360 in both cases. So that's my answer. This is definitely about multiples. Okay, we did a multiple as a block here like this. Okay, we did a multiple about a block here. So this is about equal groups and multiples, and now we're taking unequal groups as kind of a second step to the whole thing and adding them together. All right. Again, the same thing. Instead of this multiplication here, I could have done 24 plus 24 plus 24 plus 24. It just seems to me that's getting too pedantic at this level, especially as we get into uglier numbers. It's cool when you have 3 and 4, and we can do 3 4 times and get 12. But when you have 99 and 168 or something, it just doesn't make it doesn't make any sense to do it that way. So this is also about knowing your multiplication table. It involved double-digit addition, double-digit multiplication, right? And this is about groups, right? So it's not only about multiples. I have 8 oranges at 24 each, right? But it's about combining unlike groups as well. So we have equal parts and unequal parts as well here. All right. Hey, guess what? We're done. And what you're going to do now is, since you enjoyed this so well, you're going to smash the like button. You're going to subscribe to the channel, and you're going to wait for the next part of this. Peace out, y'all.